The primary purpose of IEE standard in this context is to provide uniform and accurate methods for testing motor performance. There are three key standards you should know. First is IEE 112. This sets the standard test procedures for qualified induction motors helping us measure efficiency, torque, and power factor. Next, IEE 43, which outlines the recommended practice for testing against resistance crucial for predictive short circuit. Finally, IEE 841 deals with specification for 722 motor with its harsh environment.
For the first one, I would like to tell about the IEE 112 standard test procedure for polypropylene in induction motor. So for the purpose for that, it will provide uniform and accurate method for testing motor performance, and it is also efficient, secure, speed, power factor. After that, for the for the IEE 112, the relevant it is for ensure motor meet requirement performance specification. For the second one, I like to tell to establish proper procedure for testing the installation resistance of motor wheels. After that, for relevant for IEE 43. The number is for IEE 40, and for the relevant one is prevent electrical fault such as short circuit and ground fault. The third one is the purpose for IEE 841 to define design, construction, and performance requirements for motor use in harsh and demanding instruction in environments. For the IEE 841, it is relevant to improve reliability in heavy industrial like oil and gas, petrochemical, and mining.
The IEC 60034 series in the Bible Verses subline covering general requirements like temperature, price limit, and cooling method. Step 5 define the IP code or degrees of protection. For example, an IP55 motor is protected against dust and water jet. Part 30 classify motor efficiency from IE1 standard up to IE4 super premium. The relevance here is clear. The IC standard helps industry with energy efficiency motor ensure they can survive the environment they are installed in.
The first one is IEC 60034/1. So it is specifically limited for temperature rise and cooling method. And for that IEC 60034, it is relevant to maintain stable performance under normal supply verification. After that, for IEC 60034/2, so number 2 is for provide standard method for measuring motor losses or calculating efficiency. And it is relevant to help industries choose energy efficient motors. After that, for the IEC 60034/5, it's defined purpose for defined level of protection against dust and water in the IP rating system. And it will relevant to reduce the risk of motor failure in harsh or outdoor installation. After that, the last one is for IEC 60034/30. It will specifically global efficiency classes like IE1, IE2, IE3, and IE4. Second one, OSHA 9010-269, which provides safety requirement for work on a high voltage system, and it's relevant to ensure safety handling of generators transformer, and power equipment. After the last one is OSHA 19-302, 302/308. Um, it is for purpose for ensure proper wiring, grounding, after that overcurrent protection and equipment labeling. It is relevant to ensure machines are safely installed and complete with safety codes.
There are three main articles to focus on. Article 430 specifies how to size wire and select the right switch or breaker for motor overload protection. Article 250 is discover grounding and bonding it. Ensure that motor frames and bonding to earth to prevent short hazards. Article 445 is provide the installation requirements specifically for generator following the NEC prevent overheating, fire, and equipment damage during electrical fault. So, in summary, for my part, HEE help us test the machine. HEC help us clarify and protect the machine. OSHA protects the worker and the NEC ensure safe installation. By following this standard, we ensure not just compliance, but the safety and longevity of our electrical system.
It is for provide rules for proper motor wiring and conductor civil, and it is relevant to prevent overheating, damage, and electric fault. After that, the second one is NEC Article 250. It is designed to method of safety fault current, and it is relevant to reduce risk of equipment damage during fault. The last one is NEC Article 445. It is designed to protect, control, and overcurrent protection rules, and it will prevent backfeeding, overload, and unsafe switching current.
Legal compliance is important to ensure AC and DC machines operate safely, protect workers' equipment and the environment, and comply with national laws and engineering standards. So, without compliance, electrical machines can cause serious accidents and legal consequences. Law and authorities. So in Malaysia, several laws and authorities regulate electrical machine operation. The Electricity Supply Act 1990 ensures that all electrical equipment is safely installed and approved. The Electricity Regulation 1994 cover wiring, testing, installation and earthing and require work to be done by competent persons such as chargeman or wireman. The Occupational Safety and Health Act 1994 and DOSH focus on protecting workers from electrical and mechanical hazards. Suruhanjaya Tenaga enforces MSIEC standards and handles licensing inspections and approvals. Safety protocols are required to reduce risk during machine operation. These include following high voltage safety procedure, using personal protective equipment, and installing guards for rotating parts. From an environmental perspective, electrical machines must not cause oil leakage, excessive noise, or overheating. Energy efficient machines are encouraged to reduce environmental impact. To ensure compliance, certifications such as ST approval, IEC or IEEA, manufacturer compliance, and DOSH inspection reports are required. Both AC and DC machines must meet general safety requirements. This includes correct cable sizing, adequate ventilation, and installation of overload and fault protection devices. Grounding is very important and must follow MSIEC 60364 or IEE 80 standards to prevent electric shock and equipment damage. Installation must comply with IEC 60034 and installation resistance testing using mega must be done regularly to ensure safe operation. Auto is required by OSHA and is critical during maintenance work. The procedure involves switching off the machine, isolating the power source, applying a lock, attaching a tag, and verifying zero voltage. This procedure prevents accidental startup and protects workers from electrocution or mechanical injury. So, in summary, legal compliance for electrical machines in Malaysia involve following the Electricity Supply Act, Electricity Regulations, OSHA, DOSH and Suruhanjaya Tenaga requirements. AC and DC machines must comply with grounding, insulation, and safety protection standards. Lockout and tagout procedures are essential for maintaining safety. So overall, the compliance helps prevent accidents, protect the environment, and avoid legal penalty.
For my part, I have to describe a hypothetical scenario in which an engineer needs to ensure that a new AC or DC machine installation complies with safety and legal requirements. Second, I need to outline the steps the engineer should take to comply with standards and regulations from installation to operation. Situation is an engineer is responsible for installing a three-phase AC induction motor to drive a conveyor belt in a food processing factory. The motor operates continuously and is exposed to dust and moisture. To comply with safety and legal requirements, the engineer selects a motor with an appropriate IP55 protection rating and ensures it meets IEC 60034 standards. Proper earthing, overload relays, and circuit breakers are installed. Guards are fit around rotating parts and emergency stop switches are provided. The installation is inspected and approved by Suruhanjaya Tenaga ST before commissioning. So this one, the red part is about our system, which is our group decided to choose three-phase AC induction motor for conveyor belt in a food processing factory. So for IP55 protection rating, IEC 60034 earthing, overload relays and circuit breakers are the rules or the laws that we have to follow for the safety requirements. And after we follow all the requirements and law about the safety, we have to get an approval from the Suruhanjaya Tenaga ST before we can apply the system to the industry. The next part is about the steps to comply with standards and regulations. It is divided to 5. It's about planning and design. Engineer needs to make sure to select motor compliant with IEC 60034 and suitable IP rating IP55. The next part is engineer needs to ensure correct voltage, power rating and duty cycle is used for the system. And second is about legal approval, which is engineer needs to ensure with work is done by a competent wireman or chargeman. And the next part is engineer needs to submit installation plan to Suruhanjaya Tenaga ST to get an approval for the system to be applied to the industry. And third is about installation, which is engineer needs to follow MS IEC 60364 or NEC Article 430 for cable sizing and protection. And second, engineer needs to install overload relay, circuit breaker on emergency stop for in case of the short circuit or overload or surge happen to the system. And the next part is engineer needs to provide guarding for rotating parts, for the motor parts, for its safety. And the next part is about testing. Engineer needs to perform installation resistance tests and check phase sequence and rotation direction. And the last part is about operation, which is engineer needs to commission the motor after ST approval. And lastly, needs to monitor current, temperature, and speed during operation of the system.
The reflection of this assignment. Safety standard and legal requirements are essential in electrical engineering because electrical machines involve high voltage, moving part, and hazardous environment can endanger worker and equipment. Next, technical standards such as IEC 634 and IEEE ensure electrical machines are designed and operated within safe limits, improving reliability and reducing failure. The third one is legal compliance enforced by authorities like Suruhanjaya, ensure only qualified personnel install and approve electrical system enhancing workplace safety. This reduce unsafe practice and ensure national safety laws are followed. For the fourth one is proper implementation of safety measurements such as earthing, overload protection, guards, emergency stop. It will minimize risk of electrical shock, fire, and mechanical injury. Non-compliance with standard can result in serious safety hazard, equipment damage, production downtime, and contamination risk in industrial environment. Failure to meet legal requirements can lead to penalties, shutdown, financial loss, and damage to professional reputation. Overall, adherence to safety standards and legal requirements ensures safe operational approval and long-term reliability of electrical machine systems.